Hi, ma'am. This is Tekoshi from IDA, and my roll number is 37. And my topic for Tech Talk for whose subject is the history of software engineering. So, coming to the introduction, software engineering has evolved over the time from being considered an art to becoming a recognized engineering discipline. In the early days of computing, software development was primarily done by individuals or small teams who wrote code based on their own experiences and knowledge. This approach was often referred as hacking or programming by intuition. As the field of computing grew, it became apparent that this approach was not sustainable and that a more structured and a systematic approach was needed. In the 1960s and 1970s, the field of software engineering began to take a shape. Researchers and practitioners began to develop formal methods for software development and designing, such as structured programming and the use of flowcharts to represent algorithms. In 1968, a conference on software engineering was held, and the term software engineering was officially coined. In the following decades, software engineering continued to evolve and mature. The introduction of object oriented programming in the 1980s led to a shift in how software was designed and developed. The 1990s saw the emergence of the agile software development methodologies, which emphasized flexibility and responsiveness to change. Today, software engineering is a well established field with its own set of best practices, methodologies, and tools. It is considered as a discipline of engineering and follows the same principles like any other engineering field. In summary, software engineering has evolved from an art to a discipline with its own set of best practices, methodologies, and tools. The field has grown or matured over time with new technologies, new approaches being developed to improve the design and development of the software. So, software evolution. So, let us see a flow chart for software evolution process. So, generally, it has change requests, impact analysis, release planning, change implementation, system release, and coming to release planning, it has further divided into three things, that is fault repair, platform adaptation, and system enhancement. Software evolution is a term which refers to the process of developing software initially, then timely updating it for various reasons, that is, to add new features or to remove absolute functionalities, etc. The evolution process includes fundamental activities of change analysis, release planning, system implementation, and releasing a system to customers. The cost and impact of these changes are accessed to see how much system is affected by the change and how much it might cost to implement the change. In the proposed changes are accepted, a new release of software system is planned. During release planning, all the proposed changes, that is fault repair, fault adaptation, and new functionalities are being considered. A design is then made on which changes to implement in the next version of the system. The process of change implementation is an iteration of the development process where the revisions to the systems are designed, implemented, and tested. So, change in requirement with time. With the passes of time, the organization's need and modus operandi of working and sustainability. So, after a period of time, every organization need to make some changes on what they're working. So, frequently changing time tools, that is software that they are using need to change for maximizing the performance. So, in a regular period of times or in regular intervals of time, any company or any organization have to update their software so that you will get a maximum performance rate. Next is environment change. As the working environment changes, the things that are tools that enable us to work in that environment also changes. Proportionally, same happens in the software world. As the working environment changes, then the organizations need to reintroduce the old software with updated features and functionalities to adapt to the new environment. Next is errors and bugs. As the age of deployed software within an organization increases, their presence feasibility decreases, and efficiency to bear the increasing complexity workload also continuously degrades. So, in that case, it becomes necessary to avoid use of obsolete and aged software. All such obsolete softwares need to undergo the evolution process in order to become robust as per the workload complexity of the current environment. Next is security risks. Using outdated software within an organization may lead you to at the verge of various software-based cyber attacks and could expose your confidential data illegally associated with the software that is in use. So, it becomes necessary to avoid such security breaches through a regular assessment of the security patches or modules are used within the software. If the software isn't robust enough to bear the current occurring cyber attacks must be changed or adapted. So, at regular intervals of time, if you're not changing your software and if you're using the old software only, then your data is prone to cyber attacks. So, you may face many threats, you may face many vulnerabilities, many things. So, according to the versions, you have to use the new software, and it's better you avoid using the outdated software. Next is for having new functionality and features in order to increase the performance and fast data processing and other functionalities. An organization need to continuously evaluate the software throughout its life cycle so that stakeholders and clients of the product could work efficiently. So this is the development of a software. It is a cycle. It has 7 to 8 stages. So first is supporting, next is planning, analysis, design, implementation, testing, evaluation, and release. So after it passes through all the stages, only that particular software will be released into the market. So first you have to plan what is going to happen, how will it be performed. You have to analyze it. Then you have to design like a blueprint. You're going to design it. Then you are going to implement it. Then you are going to test it. After you test it, all the things are correct. Then you will evaluate it and then release it. After all the stages are done, then only a product or a software can be developed and it can be released into the market for the use. So these are the main steps that have to be followed. So this is the development life cycle of a software. So laws used for software evolution. Laws of continuing changing. This law states that any software system that represents some real world or reality undergoes continuous changes or become progressively less useful in that environment. So in day-to-day life, if you're using a particular software, it has to be updated at a regular intervals of time. That is your first law. Next is law of increasing complexity. As an evolving program changes, its structure becomes more complex, unless effective efforts are made to avoid this phenomena. Next is law of conservation of organization stability. Over the lifetime of a program, the rate of development of that program is approximately constant and independent of the resource devoted to the system development. The next law is law of conservation of familiarity. This law states that during the active lifetime of the program, changes made in the successive release are almost constant. So this is a life cycle which is again shown, change identification process, change proposal, software evolution, and new system. So this is how you change or update your software. First, you will identify what changes have to be made. You will propose those changes. Then your software will get updated or evaluated, and that will be given to a new system, and that will be released into the market. So this is how evolution of software basically takes place. The history of software engineering is a fascinating journey that encompasses the evolution of software development practices and methodologies. It is a field that has grown immensely since its inception, that is from mid-20th century. So first is in early computing. So this was done between 1940s and 1950s. So the birth of software engineering can be tracked back to the development of the first electronic computers such as UNIVAC, INVAC during the late 1940s and 1950s. During this period, programming was often done using low-level machine languages and assembly languages, making software development a highly technical and time-consuming process. Next is the software crisis in 1960s. In 1960s, As the complexity of software increased, a software crisis emerged. Projects were often late, over budget, and riddled with defects. This crisis led to the realization that software development needed structured process and methodologies to manage complexity and improve quality. Next is the birth of software engineering in the late 1960s. So due to the software crisis, the birth of software engineering has started. People has realized the importance of software. So the term software was coined in 1968 at the NOTA Software Engineering Conference in Germany. Software engineers, inspired by practices from other engineering disciplines, aim to apply a systematic and disciplined approach for the software development. So first is the waterfall model in 1970s. The waterfall model is one of the earliest software development methodologies, which was introduced in the 1970s. It defined a linear and sequential approach to a software development with distinct phases. So it has different phases, but it was a sequential approach, that is step-by-step process. So it has different phases. These are requirements, designing, implementation, testing, and maintenance. Next is Agile Manifesto 2001. In 2001, the Agile Manifesto was published, advocating for a more flexible and interactive approach to software development. Agile methodologies such as Scrum and Kanban gained popularity for their emphasis on collaboration, customer feedback, and adaptive development. Next is software development today. Modern software development is characterized by a wide range of methodologies and practices, including DevOps or continuous integration and delivery and containerization. Open source softwares and communities like GitHub have played a significant role in collaboration and code sharing. So these days, we are using a software in a very huge manner. So it is in huge demand, as you all know. And our lives are basically dependent on software as AI, machine learning, everything is based on software only. And these days, open source software communities such as GitHub has become so popular to share your point of views in an open way to others. So next is artificial intelligence and machine learning. So as you all know that so coming 5 years, people are saying that it is completely based on AI ML, that is artificial intelligence and machine learning. And you can also see what disasters AI is making, both in a positive and negative manner. So in recent years, the development of AI and machine learning software has become a prominent field within software engineering. It involves training and deploying neural networks, natural language processing models, and more. Next is software security. With the increasing importance of software in various aspects of life, software security has become a critical concern. Efforts to develop secure software and address vulnerabilities have grown substantially. So, still now we have learned about software engineering, what is its history, what is its importance. But coming to the security of the software, it plays a crucial role because a software is nothing but it helps in retrieving one's data. So it is essential to protect one's data from many threats and vulnerabilities. So software security has been a greater point in our day-to-day lives. So it has grown sustainably. And it became a very important part in everybody's life. So software security is important in everybody's life. Next is the future scope. What is the future scope of software engineering? Software engineering continues to evolve with advances in technology such as quantum computing, blockchaining, and edge computing. Emerging fields like quantum software engineering are on the horizon. So these are some of the scopes where you have future for software. That is, one is blockchain, as you all know, which is already going on. And you can also include AI, ML, that's artificial intelligence and machine learning, quantum computing, cloud computing. So these are all softwares that are having a very good future in the coming days. Next, what are the benefits of software engineering? There are many benefits to treating software development as an engineering discipline. Some of the key benefits include improved quality, increased productivity, greater predictability, and better communication. By following established best practices and methodologies, software engineers are able to produce higher quality software that is more reliable and less prone to errors. Coming to increased productivity, formal methods and tools can help software engineers work more efficiently and effectively, leading to increased productivity. Coming to greater predictability. By the following structured and systematic approach, software engineers can make more accurate predictions about the time and resources required to complete a project. Next, coming to better communication, software engineering practices can help ensure that all stakeholders, including developers, managers, and clients, have a clear understanding of the project's goals and requirements. Greater maintainability. Software engineering practices can help ensure that the software is designed in a way that makes it easy to maintain and update over time. Better cost management, better scalability. Software engineering provides the process and methodologies to design the software in a way that is easy to scale up or cope up with. In summary, treating software development as an engineering discipline can lead to a higher quality software that is more reliable, predictable, and maintainable, as well as increased productivity and better cost management. So some of the important points of software engineering are: software engineering has evolved from being considered an art form to being considered as an engineering discipline. The transition from art to craft involved bringing more structure and discipline to the software development process. The transition from craft to engineering discipline involved a more formalized and structured approach with a focus on using established processing and methodologies to ensure the quality and reliability of software systems. Key milestones in the transition include the publication of the book Software Engineering, which includes the methodologies, techniques, and tools to support the software development. The goal of software engineering is to deliver a functional, reliable, maintainable, and efficient software. So I hope you understood what is the history of software engineering and how it evolved and what is its important, what are its benefits and why it is required in our day-to-day life, and what are its advantages and disadvantages. Thank you so much.